Hello, it's me again. The Transfer Learning Toolkit version 3 came out, so we're going to go over what the Transfer Learning Toolkit's all about. I'm going to show you how to set it up, and then we're going to run the Facenet Jupyter Notebook. So if you guys aren't familiar with the Transfer Learning Toolkit, it allows you to use pre-configured models and training to use on your own data sets. So it comes with all kinds of models. You have the PeopleNet, DashCamNet, license plate detection, facial landmarks, gesture recognition, heart rate. It has all these things that you can do. And then the architect that it has YOLO 3 and 4, which are my favorite. The TechNet, I usually use that one. And the other ones, I don't use them too much. But like I say, YOLO's, I love it. And then this is the TLT3, the Transfer Learning train, whatever. So you can train here, all this, and this is all the things you can do. And so let's go ahead and set up the Transfer Learning Toolkit. First you got to do is you got to make sure your machine's set up. So you got to make sure you have Python 3.6 or 3.8. You got to have the Docker CE, Docker API, NVIDIA Container Toolkit, NVIDIA Container Runtime, NVIDIA Docker 2, and the NVIDIA driver for your card. So I had to update mine because this it was like 4:30. And then once you get that set up, you have to also set up a virtual environment. Because it'd be nicer everything works in your virtual environment. You can set your virtual environment up just how you want it. So these are all the things you have to do before you can get going with this. So let's do this. So we need to set up, first of all, I'm going to log into my virtual environment that I created earlier. Let's see, where are you? Let's just do it the hard way. Alright, so I've logged in there, and then what we're going to do is we're going to generate our key and the NGC. So you got to go into setup. I've already logged in. You have to have a login if you want to do this. I'm going to install the NGC CIL download. I'm running the Linux. By the way, my GPUs have a 1080 Ti, so you know that's plenty to do what you need. Copy this, paste it in there, and then we check our checksums. And then we do our paths. Okay, now I don't run this right here because I'm going to run it when I generate my key. So we're pretty much done here. So we can go back, and we'll get an API key. Now we'll generate our key. Now you're going to do the setup, and then you also have to do the Docker login. Now if I've already done my setup already, so I'm probably just going to go past it. Make sure you take this right here, this key, and copy it somewhere and put it somewhere, because you're going to need that when you run the Jupyter Notebooks, and you're also going to need that when you take the output from your Jupyter Notebook and you try to generate a Tensor RT engine in your Jetson Nano or your Xavier NX. So we got to keep that. So let's do this first. I've already have a key that I generated earlier, so we'll just use that. Hopefully it works. It doesn't like that one, so we're going to go ahead and use the one that I've generated. We'll just copy that. It likes that, and the format we're going to use is ASCII. So we've already set up like that. So then we're going to do our Docker login now. Let's go ahead and save that key, because we'll need it later. So now we're going to do is, let's get rid of you. There we go. So we're going to do our Docker login now. It needs our username. And it wants our password, which is this key we've generated. Now we're in. So we've successfully generated the NGC, and we've successfully logged into our Docker. So now we can get to running our Jupyter Notebook. So what we want to do is, so we have, let's go here. Right here, these are all the, where we can get all the Jupyter Notebooks with one big pull. So we can get all these right here. So what we can do is, you can do this two ways. You can either use this command or this command. I'm going to use this command because it just worked out good for me. Now, if you notice right here, I've already pulled them twice. Watch, when I pull this, it'll put it in there. And while it's doing that, like this page right here, it's another, tells you all the things. You can pull them down individually if you want, the Jupyter Notebooks, but this way you can pull them all down at one time. So that's more convenient. And so what I'm going to do is, since I've already been working on this one right here, you can see it installed it here. These are all the models: classification, Facenet, GestureNet, SSD, YOLO 3 and 4. So they got all that in there. But I kind of want to use this one because I've been using it. So we'll rename this one. And then we'll rename this one. All right. So what we do now is, so we're getting ready to run our Jupyter Notebooks. But before we do that, we're going to have to make sure things are set up. You have to build this file right here, TLT experiments. Because what happens is when the Jupyter Notebook outputs all its models and when it's done with things, it's going to show up in here. It'll create these Facenet, GazeNet. Anytime you run a Jupyter Notebook, it'll create these files, and then it'll load them up with all of the items that the Jupyter Notebook is doing, all the outputs. And your data usually goes in here, all the data you want that you're going to do your training with, or your own data, it goes in there. So we need that. And the other one is like this. So we got our folder, and then we got our samples. Now we're going to have to map these when we get into Jupyter Notebook. I'll show you how to do that. So what we can do is just go over here, copy this. Now if you notice, there's some things in here, right, like this. They're also in the Jupyter Notebooks. So I'll show you that too. You can do that now that you're in your virtual environment, or we can wait to the Jupyter Notebooks. So let's go ahead, paste. So now we start our Jupyter Notebooks. And then what we do is we're going to go find this file I've got right here. And this is the examples we're going to work out of. So right here, I believe that's it. And we're going to do Facenet. And this is where your specs folder is in here. So you need, if you do your training and all that, that's where the modified. And this is a conversion, Python conversion script. But let's go ahead and start Facenet. Now, all the Jupyter Notebooks, they're all set up to be on their own, because a lot of times they'll like set up the environment they have you kind of redo things, but once you set it up once, you don't have to do it again. So let's go ahead and start this. Now, here's the key. When you set this up right here, you need to set the path up. This is what you're going to modify when you run this first cell right here. So you do is you copy this path, put that there. And when you first open these up, these descriptions will not be like these. It'll say something like, set it to your local drive or set it to your local this, something like that. But this is what you can do. Your local project directory is your TLT experiments. And this is where all the outputs that the Jupyter Notebook is generating is going to place them. And then your project directory is right here, is where your samples are at. And that's where it'll pull all the information it needs to do the things that it does. So what you do is you copy this. This is the one we're going to use. Copy that path. Put it in there. Paste. Oh, you know what we forgot? We forgot our key. So we need to put our key in here. Because we're going to need this key once it generates an output that you can put over into the Nano and the TensorRT. You need this key. Everything goes together. So we got this. Now I've run through this before, so I'm going to like kind of not skip things, but like I'll show you the results of them already. We won't run them. So what happens when you do that? This sets up all your path. It maps all your paths. This maps also, and this basically tells you that where you're going. And then you run this script, and this sets all the requirements, the pip requirements or the Python requirements that you're going to need to run Facenet. Now I've already ran them, so it's just going to say I already got them. And where that is that's right here. See your samples right here? If you go in here, depths. That's where this is located, just in case you wonder what was located. So what we're going to do is, and this is all the launcher, just like every Jupyter Notebook will have this. Now we've already pretty much done everything. We've built a virtual network. We've made sure this is all done. We've done our Docker login, so we can kind of go past that. Also this too. This is in every Docker, this is in every Jupyter Notebook, but once you do it once, you don't need to do it again. Everything's already satisfied. And this basically tells you your transfer learning toolkit info. And so we need to prepare the data set. Now, what's going to happen is, see, we have Facenet here. And what happens is, when you do make directory local data, it'll create this. Now watch this. Let me rename it. So when I run this, it'll create a file. See, it created Facenet folder and the data folder. There's nothing in these, but that's where everything's going to start. The output from this Jupyter Notebook is all going to be going in there. Well, I don't need that. I got this one already set up, so let's delete that. Move to trash, and then I'll rename this. Now, what the next step, this is prepare your data set. So basically, it's going to go look to make sure you got the data set in there. I did, but usually you don't. So if you go here, and this is where it tells you to get the data set, the training, validation, and labels you're going to use. And once you download them, they go in here. Like here, here's wider face split, wider val zip, wider train. That's what all this is. So I just downloaded them, and I put them in here in my Facenet data directory. So as you can see, it sees them. And then this is it unzips them. This one unzips them all. It'll unzip everything. And then this verifies that the files are there. They're all verified that they're there. And then this this is the Python application. This is the Python script right here. And what it does is it does the conversion to the Kitty format. because the Transfer Learning Toolkit wants the kitty format before it turns it into the TF records. So what happens is when you run these, it converts the wider train and the wider validation over. And then right here, this basically tells you that you're all done and you completed it. And then this is just a text file. It just basically tells you there's a face there. And then this is the points that it's been annotated to. And then you have to prepare your TF records. So you see you run this. And this is basically the specs that it's going to follow when it runs the TF records, converts it into TF records. Sometimes, like, if you're running JPEGs, you got JPEGs instead of PNGs, you would put JPEG there. And then this also does the splits, and this is where it's going to go, training, so it'll end up right there. So that's the spec file for when you run this. So once you run this, it'll do all that stuff. It'll do the split and the training, the face split, and all that stuff. And then it puts them all back in this data folder. Turns them into TF records. See where TF records, training, validation. That's what it'll do. And then this is when it does it successfully. This is what it'll look like. And then we're gonna create a directory for the TF records output and the validation. When you do that, looks like this. So then it goes through and we check it. Our training file and our validation file. So they're full of stuff, so they're good to go. So now we're ready to download our pre-trained model. And what happens is you go to here, download it, and I found the fastest way to find it is basically copy this. And this works with all the Jupyter notebooks. Go to your registry, model registry. Just stick it up in there. And boom, you found it. That's the quickest way to find it. And then you download the model. Let's see. So and then when you download the model, it'll be in your downloads. And it generally comes down as file, and you have to unzip it. File zip, that's your model. And when you unzip it, you can take it and then you put it in your, I think it's called, where do they want it put at? In the pre-trained models. Let's see. Where pre-trained models. So you put it in there, okay? And then once you got it in there, you can double check. You run this. This makes the directory for pre-trained model. This will make that directory right there. And then this is, they'll check and see if there's something in there. There should be something in there. Oh, pre-trained model file. Found pre-trained model. So it says there's a model in there. Now, what we can do is now we need to try set our training specs, how we want it to train. You know, a lot of times, if your extensions are JPEGs, you got to change this. Sometimes I generally leave this alone. If you're going to run a different model, like a different type of model instead of ResNet, you would do that in here if you're going to change the layers. And what this is, how this is located, if you go to here, your specs file, this where all that's located. So you actually wanted to edit that. What is that? That's the Facenet Train ResNet 18 Kitty. If you actually wanted to edit it, let's see, right there. You would go in here, and this is where you can actually edit it. And once you edit in here and save it, then that when you go to run it here, it's in here for you. And then you run your training. Like I say, you just go ahead and run this. Run the training. So first we evaluate to make sure everything's good to go. You know, your results should look like this when everything's good. And then you run your training, you know, depending on how many GPUs you got. That's set up at the very top. I got 1 GPU, and it basically just starts the training. Now this training, this one it probably ran for like 5 hours. So, you know, and you'll, these are the results. It's going through all the training. So these are the results you should get when you're training. And once you get to the end, it looks like that. And then what you can do is we'll check the epoch, or the model for each epoch. Do that. Then we evaluate the trained model to make sure it's evaluated. And you run this, and this is the results you should get. There's that. And then we want to prune it. So you do this, and it'll make the experiment directory prune file. It'll generate this file, this folder, excuse me. And then you want to set how you want it to prune, what you want it to do. I generally leave this alone, you know, because I haven't practiced enough with it to really understand how what to tweak on it. When you run that, you get this. And then you run this, it says that there's a TLT item in the prune folder. And then we retrain the prune model. So this is the spec file. Like if you want to make any more modifications to how it's trained, like I say, that's located here. It's located in here. So if you want to change it, this is where you do it. And then what you do is go ahead and retrain it. So you run this, and it does the retraining. And the results should look like this. Like I say, and this took another 4 hours to do. And then you go ahead and check it. You run this, and it checks it. And then we evaluate it, how the model did. So we run this, and it evaluates it. By the way, this takes about 15 minutes to run, the evaluations. And you should get results that look similar to this. All right, so now that we're done retraining it, let's visualize the inference on it. So when you run this, it runs inference on some images with what you've trained. And you get this kind of results. These are the results you get. And then right here, this is where we set up how the images, matplotlib. This is how we're going to display the images. And then we can see right here. So let's go ahead and run that. And we'll see what kind of job we did. As you can see, let's go. You know, so it did a pretty good job. You know, like I say, you can use your own, you want to train it on your own data. That's what this is all about. You know, get your own data and train it all yourself. So it did a pretty good job. Now it's time to deploy it. So generally when I deploy this, it's going to go on a Jetson Nano or Xavier NX. So the first thing we need to do is make the experimental directory file and build the TLT, the ETLT folder files. Sorry. So that's this, and this is the one. This is the folder or the file that you're probably going to put on a thumb drive or whatever, and take it with you and deploy it wherever you go. So I've already kind of run this, and you can see it's made this. It's making this folder right here, this file, excuse me. So it makes that, and then what we're going to do is then we're going to convert it into a TRT engine. So when that's done, let's see, let's pause this real quick. All right, so we created this right here. And then now we want to convert it. This will check, see what's in there in that folder. It's basically checks what's in this experimental dir final folder. And then now we want to generate a TensorRT engine. And this is the one that is generally, you do this when you do this at the Jetson Nano or Xavier NX. You do it in there. But we'll do it in here. What's nice about NVIDIA's new Jupyter notebooks is they let you run Inference in the Jupyter notebook on the TensorRT engine. So that's pretty cool. So let's pause while it does that. Okay, so once this is run, you should have created this right here. Now, like I said, generally this is going to go into a Xavier NX or a Jetson Nano. So you're going to need this converter for the Nano and Xavier. So what I do, since this experiment director final folder is going to contain everything that I'm going to transfer over, I generally download it into that folder. And it's convenient when I put it on the Nano and the Xavier. As you see, I put the converter in there. This is the converter. So now you got a nice little file folder you can put on the thumb drive and just take it anywhere you want to go. Now, here's a cool thing. Now we're going to run Inference on the TensorRT engine. So they run this right here, and then we can visualize it. And this is with the TensorRT engine, this is basically the results you're going to get when you run it on the Xavier NX or Jetson Nano. You see, we found all this. It's the same thing. So, very good. So that's about it. I hope you guys, this helps somebody. So that's what it's all about, is like helping. Well, all right. Well, thank you very much, and good luck.